Problem number 6. For a given length of coaxial cable with distributed capacitance of 48.3 picofarad per meters and distributed inductance 241.56 nanohenry per meter, determine the velocity factor and the velocity of propagation. So medyo malabo tong formula na to, no? Sabi for a given length pero hindi naman binigay yung length. Alright, so the velocity of propagation can be defined as the length of the cable or the distance divided by the time delay. And the time delay, the formula for the time delay is equal to the square root of L times C. So we can say that the velocity of propagation is equal to the distance or the length of the cable divided by the square root of LC. But here, hindi nga given yung length. But as you notice, the L or the inductance and yung capacitance, okay, yung given values nila are given in terms of farad per meter and Henry per meter. So, sinasabi dito na this inductance, okay, yung inductance is magbabago pa depende sa length ng cable and ganun din yung capacitance. So, we can say that in any given length, okay, kahit anong length, okay, the velocity factor and the velocity of propagation will always be the same. Since it is velocity, okay, the velocity is primarily dependent sa material na ginamit, okay, and ganun din yung velocity of propagation. So, let's say the distance is 1 meter. Okay, so our inductance naman ngayon will be 241.56 nanohenry. Okay, so since per meter yon. So, minultiply natin sa 1 meter na distance. So, 241.56 nanohenries. Ganon din yung capacitance. That is 48.3 picofarad. Okay, so substitute natin the velocity of propagation is actually equal to 1 over the square root of LC. That is 241.56. Oops. Kulang yung space. Purahin natin. That is 1 over 241.56 nanohenry. Oh, sorry, that is square root times the capacitance na 48.3 picofarad. So we have the velocity of propagation is equal to 292.76 times 10 raised to 6 meters per second. Now, to calculate for the velocity of sorry, meron na tayong velocity of propagation. Now, to calculate the velocity factor, we have the basic formula. The velocity of propagation is equal to the velocity factor multiplied by the velocity in free space. So, the velocity factor will be equal to the velocity of propagation divided by the velocity in free space, and this is equal to na 292.76 times 10 raised to 6 divided by 3 times 10 raised to 8. Okay? Meters per seconds and meters per seconds din to, so makakancel. The velocity factor will be unitless. So the velocity factor is equal to 0.976. So this is unitless. So here, we have the velocity of propagation that is 292.76 times 10 raised to 6 meters per second, and the velocity factor that is equal to 0.976. Alright.